Hello everyone, welcome back to our channel Problematical. We'll be discussing exercise 1.6 from chapter 1 sets, class 11th maths NCERT. The first question is, if x and y are two sets such that n of x is 17, n of y is 23 and n of x union y is 38, find n of x intersection y. Now we know the formula between x union y, x intersection y, n of number of elements in x union y is equals to number of elements in x plus number of elements in y minus number of elements in x intersection y. This is what you're supposed to calculate. These three are mentioned to you. So n of x intersection y, this on left hand side and this term on right hand side, we have n of x plus n of y minus n of x union y. Using the values, 17 plus 23 is equal, minus 38. This will be equals to 40 minus 38, which is 2. N of x intersection y is equals to 2. Next, if x and y are two sets such that x union y is 18, that means number of x union y is 18 elements. X has 8 elements, n of x is 8, and y has 15 elements, n of y is 15. How many elements does x intersection y possesses or have? It's the same as the previous question, so you can directly write n of x intersection y is equals to n of x plus n of y minus n of x union y. This is 8 plus 15 minus 18. 8 plus 15, 23 minus 18, which is equals to 5. Next, in a group of 400 people, 250 speak English, 250 speak Hindi, 200 speak English. How many speak both Hindi and English? Now it's given to you that there is a group of 400 people, and in this group, amongst these people, there are only two language in English and Hindi speaking people. So what you'll do is let E be the set of people who speak Hindi, and B be the set of people who speak English. Therefore, the group is 400 people. So total group is mentioned, which means n of A union B is mentioned to you. N of A union B is given to you as 400. Apart from this, n of A will be equal to 250 and n of B will be equal to 200. You have to find out how many people speak both Hindi and English. Number of people who speak both Hindi and English. Is equals to question mark. So this is in something like this, and both A and B. Both dash and dash, any set, say x and y, or any words here, Hindi and English. Hindi speaking people are considered as A, English speaking as B. Both this and this is mentioned. That means the element should be present in both the sets, which means it is equivalent to X intersection Y. So you have to calculate over here N of A intersection B. This is asked. Again, we have the formula for this. N of A intersection B is equals to N of A plus N of B minus N of A union B. Substituting the values, 250 plus 200 minus 400. This is 450 minus 400, which is equals to 50. So N of A intersection B is equals to 50. Next, if S and T are two sets such that S has 21 elements and T has 32 elements, and S intersection T has 11 elements, how many elements does S union T have? So S and T are two sets such that S has 21 elements. So N of S is given to be 21. T has 32. N of T is equals to 32. And S intersection T, N of S intersection T is equals to 11. How many elements does S union T has? So N of S union T is to be calculated. Formula is substituting the values. This would be the answer. Since the question is in the form of statement, your answer should also be in the form of statement. Same in the previous question as well. The question was in the form of the statement. Therefore, 50 people can speak both Hindi and English. Here, how many elements does S union T have? S union T has 42 elements. Next, X and Y are two sets such that X has 40 elements, X union Y has 60 elements, and X intersection Y has 10 elements. How many elements does Y have? So, number of elements with X is equals to 40. Number of elements of Y is asked to you. Number of elements of X union Y is equals to 60. Number of elements of X intersection Y is equals to 10. Number of elements in Y is to be calculated. N of X union Y is equals to N of X plus N of Y minus N of X intersection Y. Therefore, substituting the values, 60 is equals to 40 plus N of Y minus 10. 40 minus 10, 30. On the left hand side, it will be 30. So, N of Y is equals to 30. Therefore, set Y has 30 elements. Next, in a group of 70 people, 37 like coffee, 52 like tea, and each person likes at least one of the two drinks. How many people like both coffee and tea? So it's clearly mentioned that at least one of the two drinks. Each person likes at least one of the two drinks. That means there are no people who do not like both the drinks. You have to find which like both coffee and tea. So let X be the number of people who drank coffee. Y and Y be the number of people who drank tea. Therefore, in a group of 70 people, n of x union y is equals to 70. 37 like coffee, n of x is equals to 37. 52 like tea, n of y is equals to 52. And each person likes this. How many people like both? So n of x intersection y is to be calculated by formula. Substituting the values. Calculating. The question is in the form of statement, so answer will also be in the form of statement. 19 people like both tea and coffee. In a group of 65 people, 40 like cricket, 10 like cricket and tennis. How many like cricket, tennis only and not cricket? How many like tennis? So in a group of 65 people, so it's given that the group is 65 people, and amongst this group, some like cricket and some like tennis. So definitely all people are participating in sports. Therefore, let C and T be sets of people who like cricket and tennis respectively. Therefore, n of C union T is given to be 65. N of C is equals to 40. N like both, so n of C intersection T is equals to 10. How many like tennis only and not cricket? So you have to find out. And how many like tennis? So in the second part, how many like tennis, you're supposed to calculate n of T is equals to question mark. How many like tennis only and not cricket? So n of T intersection C dash. This is one way of looking at it. Like tennis only, but not cricket. Or which is equals to n of T minus C. It's the same thing. We like tennis, but not cricket. Let's calculate the first part, n of T first. It can be directly done by the formula. C union T is equals to n of C plus n of T minus n of C intersection T. Therefore, 65 is equals to 40 plus n of T minus 10. Therefore, n of T is equals to 35. Now, you have to calculate this, n of T minus C. Yeah, you have to calculate n of T minus C. How can you do that? We know that in any particular set, if you draw a Venn diagram, if you draw these elements A and B over here, T and C, you want tennis, that means you want the circle, but not cricket. This part is cricket. So this is the region that you require. We know that the complete circle is made up by a combination of, so n of t will be equal to all the elements in t minus c united with or plus all the elements in t intersection c. N of t we have already calculated as 35. It's equals to n of t minus c plus t intersection c. T intersection c is 10. Therefore, n of t minus c is equals to 25. Therefore, 25 people like only tennis. You can even continue with and not cricket. Next, in a committee, 50 people speak French, 20 Spanish, 10 speak both French and Spanish. How many speak at least one of the two languages? That means at least. Now this is a different phrase. First, let's assign the variables and then see what we are supposed to calculate. Let F and S be sets of people speaking French and Spanish respectively. This is the case when 50 people speak French. N of F is given as 50. 20 speak Spanish. N of S is equals to 20. 10 speak both French and Spanish. So N of S intersection F is equals to 10. Now you're supposed to calculate those people who speak at least one of the two languages. If we draw a Venn diagram with these two elements, at least one of the two languages. So this portion, either the person would speak French, or the person would speak both French and Spanish, or the person would be speaking Spanish. In either of these three scenarios, the person would be speaking at least one of the two languages, either one solo language or both the languages. That is the meaning of at least one of the two languages. So here the shaded portion is F union S. This is what you're supposed to calculate. By formula, N of S union F is equals to N of F plus N of S minus N of S intersection F. Placing the values, we have 50 plus 20 minus 10, which is equals to 60. Therefore, 60 people speak at least one of the two languages. That's the end of this exercise. Thank you.